Okay, welcome to part 3 of lecture 6. If you haven't already, please make sure that you go back and do all the modifications in parts 1 and 2 to the Nimitz cafe model. I'm going to assume you've done them, and this lecture really is most impactful if you actually are doing the modifications as we talk them through. So in this part, we're going to do an alternative way to a branching where we do it by really a deterministic condition. Remember before in this previous part, we just did it by probability. Now we're going to have if-then conditions. So as is pretty standard for a line condition, you can think about in any line, if you walk up to it and it's too long, then you may not enter that line. You may go to a shorter line. And so here we're going to see how we can start to model that with Simio. So assume for our Nimitz model that students come up to the barista line, and then if there are more than 3 people waiting, then they are not going to go to the barista. They're going to go to the self-service. And if there are 3 or less, they are going to indeed join the barista line. Okay, so the connector should have a weight of 1 when the condition holds and 0 when it doesn't. Okay, so it's basically this should have a weight 1 if less than or equal to 3 and 0 if greater than 3. And that's what we're going to want. And this should have 1 if greater than 3 and 0 otherwise. Now the 3, of course, is down here. So we always have to be referring to the Q here. And actually, as it turns out, this little green guy is the representative of the GUI representative of that Q. Okay, so what we want is we're going to want to put in the condition. And when you see a statement like this, you should see this as a comparison. You want to think about that in coding terms. That it actually means is it's going to return true if this condition is true, if barista Q is greater than 3 and 0 otherwise. And just like this is going to return true if barista Q is less than or equal to 3 and false otherwise. And true and false, you should think of that in coding terms that when we convert that Boolean to numbers, it'll be 1s or 0s. Okay, so we just basically need to put the Boolean logic in there, and then it'll automatically put the weight of 1 or 0 where it should be. Okay, so we select the connector, and remember right now, if you've just, it might be 60 or 40 if you copy and pasted your code from the previous. One thing that you should note is you can create a new model, and you can just select the objects and copy and paste them if you want, or you can just modify the same model. It's really more important that you understand how to do the things than you have the separate models. But you're going to see the selection weight here when you select the different connectors. As I said, if you've been doing the other bits, if you did the probabilistic bit, this might be, this model here would be 40. This might be 40, and this might be 60 if you were doing the other part before this. Okay, and we're going to want to change that so that it has this conditional logic. Okay, so we want a conditional statement, and the conditional statements we want are here. Okay, so we're going to use the condition builder. So when you select that, when you click on that selection weight, you're going to see what we want is we want to get the barista. We want to get the barista Q. So you're going to select the barista. And then what that is called actually is the allocation queue. Okay, so you're going to want to select that option. So it's going to be barista dot allocation queue. And then what do we want there? We want the number waiting in the allocation queue. So it should be barista allocation queue dot number waiting. And we want to have that to be greater than 3. And remember, this is all for the connector to the self-service, right? When that barista queue, which is not the self-service queue, but the barista queue is greater than 3, we want all the weight to be on the self-service line. We want a weight of 1. Okay. And then, of course, if it's less than or equal to 3, so you do the same thing for the cashier to barista connector. And if it's less than or equal to 3, we want all the weight to be there. And note that these are mutually exclusive conditions. In other words, only one of these will ever be true and only one of these will ever be false. So that's exactly what we want, because we don't want, you have to be careful with your logic sometimes. If you put in the logic so that you can have both of them true, then you would actually just turn this into a coin flip. Again, it would revert back to probabilistic branching. By putting it this way, we have deterministic branching. It's only going to go to the barista if the Q is 3 or less, and it's only going to go to the self-service if the barista Q is strictly greater than 3. Okay, so if we do that and you have that all in there, then what you're going to see is something like this should happen. If there's 2 customers in the queue, then remember here, connector 5 is the self-service. So this is to self-service. And this is to the barista. We see if there are 2 customers in queue, then we do not, the logic would say there's a 0 to the self-service line. And it's, of course, a 1 to the barista. And then if there's 3 in queue, then again, you would go to the barista and not the self-service. Okay, and what this puts is then 4 in the line, and of course at that point it switches the weight to the self-service and no weight on the barista. Okay. If you run this model, it turns out that you'll see that the maximum number in station, the maximum weighting, will actually be 4. But here's the interesting thing. It turns out that this condition is actually not that restrictive. In fact, most people are going to be going to the barista, according to my model, and very few are going to go in and out of the self-service. And, this is something that you should always do after you make an incremental change, check it. Okay, this made me happy that 4 is the maximum that could be in that queue, because that means that, okay, the condition seems to be working. This was a little bit of a question mark and actually made me check with Professor Sversko to make sure she got the same results as I did, and she did. And so that was good evidence that indeed this is all working out pretty well. With this sort of small incremental change, I felt fairly confident it was correct. But when you see these sort of extreme numbers, it is wise to check it if you're not sure what to expect.